Hi, in this video I'm going to do some problems from section 7.3. Section 7.3 is estimating a population mean. When we want to find confidence interval for estimating a population mean, we have two cases. One is sigma is not known. Sigma is standard deviation for population. If you don't have the value for sigma, here is the instruction. If sigma is not known, but the relevant requirements are satisfied, we use the student t distribution instead of normal distribution. So here's the more detailed process. And basically, if you don't have the value for sigma, as long as the requirements are satisfied, which are listed in here, then we should use student t distribution instead of normal distribution. For a student t distribution, we use t of alpha over 2 instead of z. And instead of sigma, we use s. So the formula would be t of alpha over 2 times s divided by square root of n. S is a standard deviation for sample. Since we are using a student t distribution, we also need to find degree of freedom. Degree of freedom is n minus 1. N is sample size. Once we find the value for e, which is margin of error, we subtract e from x bar. That would be the lower bound for the confidence interval. If we add e to x bar, that would be the upper bound for our confidence interval. So let's find out if we could do some problems. Section 7.3. Let's do problem number 1. Okay, for this one, it says do one of the following as appropriate. Either find the critical value z of alpha over 2 or find the critical value t of alpha over 2. Basically, if you have the value for sigma is known, we use z of alpha over 2. If we don't have the value for sigma, we use t of alpha over 2. For this problem, the confidence level is 98%, n is 25, sigma is unknown. Population appears to be normally distributed. Since the population appears to be normally distributed, that implies that our sampling distribution is also normally distributed. But since the value for sigma is not known, we're not going to use normal distribution. We're going to use t distribution, student t distribution. So we should use either b, which is t of alpha over 2, or d, which is t of alpha over 2. So these are the two which has t, but we have to see which one is that. In order to figure it out, we know the confidence level is 98%. So that means 100 minus 98 would be 2%. Alpha is 2%. And we need half of alpha. 2% divided by 2 would be 1%. So alpha is 1%, which is going to be 0.01. So let's use a StatCrunch. And since I want to find the area to the right side of that point, the area to the right side of my critical point is given to me. That's really alpha over 2. Then I need a calculator to help me find that critical value. So we need to go to Stat. We need to go to calculators. Calculators will help us to find either the area to the right side of the point or to the left side of the point, or if you have the area, you can find the point, the critical values. So that's calculators under Stat, and then we have to see which calculators we're going to use, which one of the calculator we're going to use. For this case, we have student t distribution, and that means we have to go to t. T means student t distribution. I would click on this, and then it says I need degree of freedom. degree of freedom is n minus 1. Since n is 25, 21 minus 1 is 25 minus 1 is 24. So 24 is degree of freedom. Again, I want to find the value, critical value, such that the area to the right side of that point is 2% divided by 2, which is going to be 1%, which is 0.01. So I'm going to put 0.01 in here. That's the area. So we're going to type the area in here, but I need the value to be greater than that point, because this is the area to the right side of that point. So this is the critical value, and the area to the right of that is going to be 1%. So it looks like the critical value is going to be 2.492, which is going to be choice B, because choice D is T of alpha over 2 is 2.172, and I need 2.492. I will click on this and check answer, and that was how we do this one. Now let's see how we can do number 2. For number 2 is very similar. They're asking us to use either z of alpha over 2 or t of alpha over 2, and or say that neither of those are going to be appropriate. So right now confidence level is 99%, n is 17, sigma is 21.7, and population appears to be normally distributed. Again, since population is normally distributed approximately, then that means sampling distribution, the sampling will also be normally distributed, and in this case sigma is known. When sigma is known, we're going to use z of alpha over 2, normal distribution. So z of alpha over 2 would be either choice A or choice D, but we have to see which one of those we are going to choose. Again, to figure it out, we know the confidence level is 99%. 100 minus 99 is 1%. 1% divided by 2 would be 0.5%, which is going to be 0.005. So I'm going to open the StatCrunch again. I have to go to stat calculators. This time, since I'm going to use normal distribution, z of alpha over 2, I'm not going to go to t anymore. I'm going to normal. So I go to normal because that's normal distribution, and that gives me z of alpha over 2. For normal distribution, if I know I want z of alpha over 2, that means that if I have a standard normal, the mean would be 0, standard deviation would be 1, and I want the value to the right side to be 0.05. So I'm going to put 0.005, 0.005, because that's 0.5%, which is half of alpha, because alpha is 1%. So the area to the right side of this normal distribution is, to this point, the critical value is going to be 0.005, and then I needed to put greater than, so I'm going to choose greater than, and that's the area to the right of this point. So that is my critical value, which is going to be 2.575. If I look at my choices in here, 2.575 is D, because A is 2.33. So I'll choose this one, and that should be good. Okay, so let's see what we can do for number 3. For number 3, we want to find confidence interval. And again, this is for mean, and we have to see, well, which do we have sigma or we don't. In this case, they have given us all the information, confidence, 98% confidence level, and 51, and then x bar is 4.0 kilogram, and s is equals to 5.2 kilogram. First of all, it says that assume that the population does not exhibit a normal distribution. Our population is not normally distributed, but since the value for n is larger than 30, is 51, that means our sampling distribution is going to be normally distributed. So that was one of the requirements. If the population does not have a normal distribution, but the sample size is larger than 30, then that implies that the sampling distribution would be normally distributed. Now, the other case is that, well, are you going to use student t or normal distribution? Are we going to use z of alpha over 2 or t of alpha over 2? In here, since s is given to us, that means we don't have the value for sigma. Anytime we don't have value for sigma, we use t instead of z. So let's go to StatCrunch, and since we're trying to find the confidence interval, for this problem, I need to go to stat, and I'm not going to go to calculator like I did for problem number 1 and 2. I'm going to go to either I have to choose z statistics or t statistics. These are for mean. And in section 7.2, we went to proportion statistics because that was for proportion confidence interval. But here, for mean, you have to choose one of these. Again, since I don't have the value for sigma and I have to estimate using s, I have to use t. So I have to go to t statistics, one sample with summary, and put all the information. The information, the sample mean is 4 kilogram. I'm going to put 4.0. And then sample standard deviation is 5.2. Sample size is 51. And here, instead of hypothesis test, I need confidence interval. I have to make sure you click on that. 98%, so I change this one to 0.98. And again, since this is a student t distribution, we need degree of freedom as well, but we don't have to put it in here. Once we put the sample size, this StatCrunch will take care of that, and we don't have to tell him what is the degree of freedom because it will know how to calculate it itself. So all I need to do is just put in and then compute. Here is my lower limit. Let's copy that, put it in here, paste it, and they wanted to round it to 1 decimal place, so that makes it 2.23. That's the lower limit, and to do the upper limit, I have this number, copy it and paste it, and this one also 1 decimal place, so that would be 5.7. Check answer. So that was good. And then, is the confidence interval affected by the fact that the data appears to be from a population that is not normally distributed? No, because sample size is large enough, so that's fine. If the sample size is large enough, we'll be fine. And then number 4 is going to be very similar, and we're going to use the same thing, t distribution. And I'm not going to do that because it's going to be very similar. I'm going to move on to number 6. Number 6, if you notice in here, sigma is given to us this time instead of s. So it says randomly selected the student participated in an experiment test. Their ability to test their ability to determine 1 minute or 60 seconds has passed. 40 students yielded a sample mean of 57.7. So